Hello students, myself Mehul Pudia from LJIET Institutes of Engineering and Technology. So in last session we discussed one numerical based on reflection about line y is equal to mx plus c, and in today's session we have to learn one new topic, that is three-dimensional geometric transformation. Okay. So what is three-dimensional geometric transformation? So in this chapter we already discussed what is two-dimensional geometric transformation. Also we derive equation of all type of two-dimensional geometric transformation. Next we discuss homogeneous geometric transformation. Also we derive equation for the homogeneous geometric transformation, for the translation, for the rotation, for the reflection, shearing, and for the scaling. Now, what is 3D rotation in computer graphics? Now, what is the three-dimensional rotation in computer graphics? In 3D rotation, we have to give rotation in either in anti-clockwise direction or in clockwise direction. We already derived equation of the 3D rotation. Clear? Like anti-clockwise rotation equation, that is cos theta sin theta 0 minus sin theta cos theta 0 0 0 1. Okay, and what is the equation of clockwise rotation? If you put instead of theta, if you put minus theta, at that time anti-clockwise rotation equation converted into the clockwise rotation equation. So what in 3D rotation in computer graphics? In computer graphics, 3D rotation is a process of rotating an object with respect to an angle in three-dimensional plane. Consider a point of object O has to be rotated from one angle to another angle in 3D plane. So let's consider initial coordinate of object O, that is x old, y old, and z old. We have to rotate one point, and that point coordinate, that is x old, y old, and z old. After that we have to give rotation in anti-clockwise direction, and that point move to the new position. And new position coordinate, that is x new, y new, and z new. Initial angle of the object O with respect to origin, that is phi. Initially the original point make one angle with x axis, that is phi, and rotating angle, that is theta. Means already that point generate one angle with x axis, that is phi. After that we have to rotate this point in anti-clockwise direction at angle theta. Okay, so that is the rotating angle theta. New coordinate of object O after rotation, that is x new, y new, and z new. Now we have to derive relationship between x new, y new, and z new with x old, y old, and z old. Okay. So in this case, total three types of rotation is generated. First, rotation about x-axis, rotation about y-axis, and rotation about z-axis. So we have to generate total 6 equation of the rotation. How you can generate this 6 equation of the rotation? Like once you find out rotation about x-axis. So once you find out rotation about x-axis and in anti-clockwise direction and clockwise direction, that is the two equation. If you find rotation about y-axis, at that time also you have to find out anti-clockwise rotation equation and clockwise rotation equation, and rotation about z-axis. At that time again you have to find equation of rotation in clockwise direction and anti-clockwise direction. So first we have to derive equation for the rotation about x-axis. Okay. So once you rotate any of the object about x-axis, at that time rotation occurs in yz plane. So what is the meaning of that? The meaning of that is once you rotate any of the object about x-axis, at that time x coordinate of the object remain constant, only y coordinate and z coordinate will change, because rotation is occurs in yz plane, because you give rotation about x-axis. Okay, so the rotation is achieved by using following rotation equation. X new is equal to x old. Why? Because we give rotation about x-axis. So rotation take place only in the yz plane. Okay, so what is y new? Y new is equal to y old cos theta minus z old sin theta, and z new is equal to y old sin theta plus z old cos theta. That is the relation already we derive in two-dimensional geometric transformation. Okay, so we have to use that equation over here directly. Now we have to convert this equation into matrix form like this. X nu, y nu, z nu, 1 is equal to 1 0 0 0 0 cos theta minus sin theta 0 0 sin theta cos theta 0 0 0 0 and 1, and one matrix in multiplication, that is x old, y old, z old and 1. If you multiply these two matrices and you will get above three equations. If you want to find out value of x nu, at that time you have to multiply first row with first column. If you want to find out value of y nu, at that time you have to multiply second row with first column. Same way, if you want to find out z nu, at that time you have to multiply third row with first column and you will get above three equations. Okay, so in this case we follow the reverse process. From the equation we converted that equation into matrix multiplication form. Okay, if you multiply like first row first column, 1 into x old plus 0 into y old plus 0 into z old plus 0 into 1, definitely you will get answer, that is x old. So x nu and x old. So same way you can find out y nu and z. Okay, so this is the simple x-axis rotation in anti-clockwise direction. If you want to find out rotation for the clockwise direction, so you have to just replace theta with minus theta and you will get equation of the clockwise rotation. So this is the rotation in x-axis. Now for the y-axis rotation. So same way, if you rotate any of the object about y-axis, at that time y coordinate of the object remain constant and rotation take place in xz plane. If rotation take place in xz plane, at that time only x and z coordinate will change. So we have to use that fundamental and derive equation of that. That is x nu is equal to z old sin theta plus x old cos theta. Y nu is equal to y old because we give rotation about y axis, and z nu is equal to y old cos theta minus x old sin theta. Now using these three equations, we have to convert these three equations into matrix multiplication form like this. So this is the matrix equation x nu, y nu, z nu and 1. These three equations converted into matrix form in single equation, in single matrix equation like this. Cos theta 0, sin theta 0, 0, 1, 0, 0, minus sin theta 0, cos theta 0, 0, 0, 0, 1. And the old point coordinate, that is x old, y old, z old and 1. If you multiply first row with first column and you will get answer of the x nu. If you multiply second row with first column and you will get answer of the y nu. If you multiply third row with first column and you will get answer of the z nu. Okay, so suppose if you multiply first row with first column, then cos theta into x old plus 0 into y old plus sin theta into z old plus 0 into 1, and you will get answer of x is equal to z old sin theta plus x old cos theta. Same way you can find out y nu and z nu using matrix multiplication. So this is the y-axis rotation. Now same way we have to derive equation for the z-axis rotation. So fundamental remains same. If you rotate any of the object about z-axis, at that time z coordinate of the object remain constant and rotation take place in xy plane. So only x coordinate and y coordinate will change. So we have we derive one relation of in two-dimensional plane for the rotation. So we have to use that equation over here. So x nu is equal to x old cos theta minus y old sin theta, and y nu is equal to x old sin theta plus y old cos theta, and z nu is equal to z old because we give rotation about z axis. So that is the equation of the axis x nu, y nu, z nu and 1. Above three equation we converted into one single matrix equation like this. Cos theta minus sin theta 0 0, sin theta cos theta 0 0, 0 0 1 0, 0 0 0 1, and in multiplication we have to put old point coordinate like x old, y old, z old. If you want to find out value of x nu, y nu and z nu, then you have to just multiply first row with first column for the x nu coordinate second row with first column for the y new coordinate, third row with first column for the z new coordinate. So this is the equation of the z-axis rotation. This equation for the anti-clockwise rotation. If you want to find out equation of the clockwise rotation, then you have to just replace theta with minus theta. Okay, and you all know, you have to remember one thing: cos of minus theta is equal to cos theta, but sin of minus theta is equal to minus sin theta. So remember this thing. So this is the z-axis rotation. So we total derive three equations of the rotation: rotation about x-axis, rotation about y-axis, and rotation about z-axis. And also for each we find out a rotation in anti-clockwise and clockwise rotation. So total 6 equations you have to remember that. Okay. So now next topic, that is three-dimensional scaling in computer graphics. Now you all know what is the fundamental of scaling. If you want to reduce or increase size of any of the object, that is the process of scaling geometric transformation. In computer graphics, scaling is a process of modifying or altering the size of object. Scaling may be used to increase or reduce size of the object. Next thing, that is scaling subject the coordinate point of original object to change. Next point, that is scaling factor determine whether the object size is to be increased or reduced. That thing already we discussed. If value of scaling factor is greater than 1, means we increase size of the object. If scaling factor value is less than 1, that means we have to reduce the size of the object. Okay. If scaling factor is greater than 1, then object size is increased. If scaling factor less than 1, then the object size is reduced. That is the simple fundamental of scaling. We already derive equation of scaling in two-dimensional plane like sx 0 0, 0 sy 0 and 0 0 1. In that case, we just give scaling in two axes, only in x coordinate and y coordinate. But in this case, we have to add one more axis, that is z axis, that is sz, scaling here about z axis. Consider a point of object O has to be scaling 3D point. Now we have to consider one point O. Initial coordinate of object O, that is x old, y old and z old. What is scaling factor of x axis? That is sx. Scaling factor of y axis, that is sy. Scaling factor for z axis, that is sz. And new coordinate of the object O after scaling, that is x new, y new and z new. Okay. Now we have if you want to scale any of the object, at that time you have to just multiply scaling factor with particular coordinate. Like if you want to find out new position of x coordinate, at that time you have to multiply scaling factor with old coordinate of that point. Like x new is equal to x old into scaling factor of x axis sx. Same way y new is equal to y old into sy and z new is equal to z old into sz. Now you have to convert these three equations into one single matrix equation like this: x new, y new, z new 1, sx 0 0 0 0, sy 0 0 0 0, sz 0 0 0 0 1, and in multiplication x old, y old, z old. If you multiply these two matrices, at that time you will get above three equations. Okay. First row with first column, you will get answer of x new. Second row first column, you will get answer of y new. Third row first column, again you will get answer of z. Okay. So this is the equation of the scaling geometric transformation, and you have to remember this equation. Okay. Now last geometric transformation process, that is 3D reflection in computer graphics. So reflection is a kind of rotation where the angle of rotation is 180 degree. Okay. The reflected object is always found on the other side of the mirror. Okay. Reflection is a similar kind of process. It is the process of mirroring. Okay. The size of reflected object is same as the size of original object. In reflection, a size of object will not change. Consider a point of object O has to be reflected in 3D plane. Now let's consider initial coordinate of object O, that is x old, y old and z old. New coordinate of reflected object, that is after reflection, that is x new, y new and z new. Now we have to derive relationship between x new and x old, y new and y old, z new and z old. Now reflection is take place, types of reflection. In 3D plane there is three types of reflection. Reflection relative to XY plane, reflection relative to YZ plane, and reflection relative to XZ plane. So first we have to start reflection relative to XY plane. So this reflection is achieved by using following reflection equation. Once you find reflection about XY plane, at that time value of Z coordinate that is converted into minus Z. Clear? You all know if you find reflection about X axis at that time in first quadrant both the coordinate is positive, but in fourth quadrant X coordinate is positive but Y coordinate is negative. Okay, so once you find reflection about XY plane, at that time you have to consider a third coordinate as a negative side. So reflection about XY plane, at that time Z coordinate you have to consider as a minus. You have to multiply with -1. Once you find reflection about YZ plane, at that time you have to consider X coordinate as a negative side. Once you find reflection about XZ plane, at that time you have to consider Y coordinate as a with negative sign. Okay. So X nu is equal to X old, Y nu is equal to Y old, and Z nu is equal to minus Z old. Why we consider Z coordinate as a minus Z old? Because we find reflection about XY plane. Once you find reflection about XY plane, at that time third coordinate converted with, because third coordinate reflected into other plane. Okay. So and now we have to convert these three equations into one single matrix form like this: X nu, Y nu, Z nu, and 1, and 1 0 0 0 0 1 0 0 0 0 minus 1 0 0 0 0 1, and in multiplication X old, Y old, Z old, and 1. If you multiply these two matrices, and you will get answer of about 3 equations. Okay, first row first column like 1 into X old plus 0 into Y old plus 0 into Z old plus 0 into 1, and you will get answer of X nu is equal to X. Same way, if you multiply second row with first column, you will get answer of Y nu. Third row with column, you will get answer of Z. Now same process we have to repeat for the reflection about YZ plane and reflection about XZ. Okay. Now reflection relative to YZ plane. So in YZ plane you have to consider X coordinate is with negative sign. So X nu is equal to minus X old, Y nu is equal to Y old, Z nu is equal to Z old. Okay, again you have to convert these three equations into matrix form like this: X nu, Y nu, Z nu, and 1. Minus 1 0 0 0 0 1 0 0 0 0 1 0 0 0 1, and in multiplication X old, Y old, Z old, and 1. If you multiply these two matrices, and you will get answer of about 3, and that is the last equation, that is reflection relative to XZ plane. Okay, so in reflection relative to XZ plane you have to consider Y coordinate with negative sign. Okay, so this reflection is achieved by using following reflection equation: X nu is equal to X old, Y nu is equal to minus Y old, and Z nu is equal to Z old. Again you have to convert these three equations into single matrix equation like this: X nu, Y nu, Z nu, and 1. In this case you have, in all the, whenever you converted any of the three equations into single matrix form, at that time you have to follow the reverse process. Okay, that is already you know. Now 1 0 0 0 0 minus 1 0 0 0 0 1 0 0 0 0 1, and in multiplication X old, Y old, Z old, and 1. That is the equation of 3D in 3-dimensional reflection relating to XZ plane. Okay, so in today's session we discuss about rotation. In rotation we derive 3 equations: rotation about x-axis, rotation about y-axis, rotation about z-axis. Then after we discuss how to derive equation of the scaling geometric transformation, and in last we derive equation of the reflection. In reflection again we derive 3 equations of reflection: reflection about xy plane, reflection about yz plane, and reflection about zx plane. So you have to remember all the equations for the 3D geometric transformation. Okay, so in next session we discuss one new topic of this chapter.